When it comes to ASME B31.3, a lot of people are surprised to know that there are no stress equations for the effect that a fitting or a component might have in a piping system. It's all based on straight pipe only. But we all know that pipe fittings, elbows, in this case branches, all have local stresses. So how are those local stresses accounted for? The alternate method for accounting for localized stresses and stresses associated with branches and fittings and components is called stress intensification factor. So what is a stress intensification factor? Well, it is simply a factor that is added per component to the pipe stress calculation for that wall thickness that accounts for the geometry of that component and the related stresses because of that geometry for stress calculation. Simply stated, it is the pipe stress calculation for straight pipe as if there were no component there times the associated stress intensification factor for that component geometry to account for the presence of that component. So exactly how is a stress intensification factor determined for a given pipe component? Let's look at the definition for stress intensification factors. The stress intensification factor is just simply a stress ratio. It's defined as the stress required to produce a cyclic through-wall failure at a circumferential weld in a straight pipe for a given number of cycles. That is divided by the stress required to produce a through-wall failure in the relevant component in the same number of cycles. In all cases for components, because of stress concentrations, the stress required to create the through-wall crack in a component in the X number of cycles will always be less than the stress required for a straight piece of pipe at the weld. Thus, the stress intensification factor will always be greater than 1. ASME B31J is the document that now defines the method for determining stress intensification factors and the calculations related to those. The SME will rarely be required to calculate an SIF because the pipe stress software deals with assigning the SIF when the component in the software is selected and placed in the piping geometry in the software. Reviewing, the stress intensity factor is really just a ratio of the stresses in a straight pipe at a weld versus a component to produce a crack at a given number of cycles. And it is applied at the location of the component whereby the stresses for that location are calculated using a straight pipe, and then the stress intensification factor multiplies those stresses to represent the presence of the component. This is just an introduction into stress intensification factors. However, because SIFs, stress intensification factors, play such a role in balance of plant that we are going to plan for in the next 18 months a full course on ASME B31J so that we can contrast the role of SIFs versus stress indices for ASME Section 3 NB.